from Kansas State University. This is Agriculture Today. Eric Atkinson with you. Here's what's coming up. K-State's Sarah Lancaster on the potential role of paraquat herbicide this crop production season as a burn-down alternative to glyphosate, which may be in short supply this spring. She'll review the very latest regulations on paraquat applications, which you producers and commercial applicators need to be familiar with. Also in Today, K-State's Terry Griffin talking about a new initiative on the part of a global network of leading precision agriculture scientists promoting on-farm crop production research. And on this week's edition of Milk Lines, further ahead, K-State's Mike Brouk will look at the latest report on milk consumption in the U.S. and what that's signaling to the dairy industry. Here on Agriculture Today. You're listening to Agriculture Today. Welcome to our Tuesday edition. Well, we want this time of year to talk about things in advance of the growing season that will help you producers along, and in this case, it has to do with weed control strategies and centering on a specific herbicide product. That is Paraquat. Paraquat is a very familiar compound to you producers out there. Sarah Lancaster has joined us once more. She is a weed management specialist with K-State Research and Extension. In that, it's been around a while, Paraquat has, Sarah. Still, there seems to be a renewed interest in this chemical heading into the 2022 growing season, you say?
Eric, I think there is a potential for that. As we think about increased glyphosate prices and concerns about glyphosate availability, Paraquat becomes a possible substitute for glyphosate, especially in those early spring burn down situations where folks are just looking for a broad spectrum weed control. So it could potentially see increased use here this spring.
And in that vein, in a few moments, we will talk of some of the things that producers need to think about in employing Paraquat in that manner. But just a quick reflection on the history of this chemical. It's been around a long while, it's quite common, and its effectiveness has proven itself over time.
Yes, Eric, Paraquat can be a very effective herbicide. And as you said, it's been around a long time. And, most of our listeners are probably very familiar with some of the extra precautions that we need to take when we're using Paraquat. So this has long been known. It recently has kind of come to the surface of things we're talking about again, because Paraquat was one of the first herbicides that was subject to these recurring re-registration reviews that all pesticides have to go through now. And as part of that re-registration review that actually started back in 2011, the EPA issued some additional safety requirements. And so they've been in place some of them have been in place for a while. But really, the whole package of those requirements is kind of just being solidified, and the labels are being updated now.
And it's not just for applicator safety purposes, it's for surrounding areas outside of any treated field, right?
That's right, Eric. So one of the things about Paraquat that is different than a lot of herbicides is that some of these requirements apply not just to the applicators, but also to individuals that are handling the product. So the folks that are loading the trucks, the folks that are transferring onto sprayers, et cetera. Whereas with a lot of herbicides, specialized training and a lot of the safety requirements are tied mostly with the applicators, the folks, in the spray rig. So, and in addition, Paraquat does have concerns for example, spraying around residential areas. Some of these new requirements include setbacks from residential areas where, folks that are not involved in the application could potentially come in contact with the spray that's on plants in the area.
Some of the things that have been implemented, and some of these are not new, but folks need to be reminded of them. Paraquat is a restricted use pesticide, correct? Therefore, one has to be certified to directly apply it.
That is correct. Paraquat, like a lot of other products that we use in our agricultural systems, is a restricted use pesticide. And in this case, that restricted use is largely because it does have potential human health impacts due to acute or that short-term exposure. And whereas a lot of our other restricted use pesticides are restricted use more for environmental concerns. So Paraquat is a little bit different in that regard.
One of the things, though, that really is being emphasized is the requirement for training on using the product. And that has continually evolved over the last several years.
So one of the things that came out with the initial proposed changes to the label, Eric, was the requirement for additional training, so product-specific training for Paraquat for any applicator or also handler. And so a couple of things about that training that might be a little different than what folks are accustomed to with other product-specific training. Number one, this training is for applicators and handlers. So applicators and handlers have to be certified, so they have to have an applicator's license, and they have to have this additional training. This additional training is offered online. It's really not too cumbersome to go through. It is time consuming, but it's not challenging. When I did it, it took 30 or 45 minutes to work through. So that training is online, and it has to be current every 3 years. And so if folks took that training when the requirements first came out, it is possible that that certificate could be expiring for them here this year. And so it'll be important for those individuals to make sure that they are current on their training for this year. And so we just put together an e-update that actually does have the link for that training.
We will tell folks about that article, which spells out much more beyond what we'll discuss today in just a second. Again, the EPA this past August put out its final interim decision for Paraquat. There were more stipulations there, were there not? And we can't go through all of them, but are there any particulars that stand out there beyond what we've discussed so far?
You know, we've mentioned the buffers. I think some other things to think about, especially for folks who are custom applicators who end up applying a lot of Paraquat, is that there are some tighter restrictions. There's some more specific guidelines around the requirements for what kind of implement or equipment needs to be used. So specifically, these new restrictions talk about if you're going to spray more than 80 acres in a day, you have to have an enclosed cab, which probably is already being done for most folks that are spraying that much anyway. The other thing to think about is things like reentry intervals related to this product. I know that some of our friends in the cotton industry were watching this portion of the proposed changes pretty carefully as they were coming out, because Paraquat can be a really important component of those harvest date applications for cotton production here in Kansas. It's a cost-effective way to get those leaves to drop. Mm-hmm. And so where we settled out on those restrictions is that there is a 7-day pre-harvest interval for, quote, Western cotton, which would be where a lot of our cotton acres would fall, and then a 3-day reentry interval for cotton in other parts of the country. And so that's a big one to think about there in terms of how we plan things to get the cotton out. Yeah.
There are particulars, again, that you need to have a look at, producers, and they're in this article that we will reference one more time here in just a second. Sarah, though, as you would recommend to producers employment of Paraquat this year for burn down in particular, what are some of the things that you'd pass along in as far as tank mixes or any other use recommendations?
Yeah, Eric, I think if folks are not used to using Paraquat, they might need to think a little bit about what they want to put in the tank with it. We know that we can see increased efficacy of Paraquat when we include a group 5 photosystem 2 inhibiting herbicide with a Paraquat application. So examples of those types of herbicides, the two that would be most common would be atrazine, if you're looking at burn down ahead of corn or sorghum, or metribuzin, if you're looking at a burn down ahead of soybeans. So those can be a couple of things that are important to think about. One other thing I would say along those veins is that, burn down could be burn down of weeds, but it could also be cover crop termination. And as we think about replacing glyphosate in that cover crop termination application, there's some data that comes out of Missouri, Arkansas area that suggests that applications of Paraquat with metribuzin and 2,4-D is really one of the most effective and most consistent applications after all of those combinations that those researchers looked at that contained glyphosate. So lots of possible ways that we might be seeing more use of this product in the spring. And we just want to make sure that folks are using it in ways that are legal and safe and going to be as effective as possible.
And to that point, not trying to scare folks away from employing Paraquat in this manner. There are extensive regs here, yes. But if one studies up, follows those, this could be a very effective tool and an alternate treatment in the case where glyphosate, for one, will be scarce.
Absolutely, Eric. We know it's an effective herbicide, and we just want to make sure that with all products, right, that folks are taking the steps they need to take to, again, be legal and safe and effective.
And we would strongly recommend that you have a look at the article that Sarah has mentioned. It's been published in the recent Agronomy E-Update newsletter, which was released this past Thursday, as a matter of fact. It is entitled, directly enough, Paraquat, What You Need to Know for Use in 2022. It runs through all of the latest stipulations on employing this herbicide. Go to agronomy.ksu.edu, click on the E-Update tab toward the upper right-hand part of the page, and access that article, again put out there just this past week. Sarah, thanks for going over this with us. We'll catch up with you again quite soon.
Thanks, Eric.
That from Sarah Lancaster, Weed Management Specialist, K-State Research and Extension. After this break, we'll bring you up to the moment on a new push for on-farm crop production experiments. How that's formally taking shape right now. Our next guest will elaborate. You're listening to Agriculture Today. Welcome back to Agriculture Today. And for the next few moments, we'll examine more closely, let's call it an initiative that's underway, and several scientists, including our guest now, have signed off on this approach to research called on-farm experimentation. Terry Griffin is with us. You'll know he's a precision agricultural economist here at Kansas State University, and he's one of quite a collection of researchers and scientists who have invested in this concept, Terry. And right to it, what is the general gist of this? It has to do with a shift agricultural research might take.
Yeah, so on-farm experimentation, when we're talking about researchers and farmers collaboratively look into how inputs and systems perform under farmers' management, is important for farm management and decision for what inputs and rates and timing that those farmers will do on their own farms next year. You know, the concept goes back, centuries. Mm-hmm. If we would think back to the early days of extension, there was very localized recommendations on nitrogen rates and so forth. And as time goes on, those local recommendations turned into state-level recommendations or tri-state recommendations due to a myriad of factors, one of which has been reduced funding for local information, local research. And a lot of farms have decided to supplement that lack of local information by conducting their own on-farm experimentation. And when we take agricultural technology, digital agriculture, all the tools that we've been talking about on your broadcast over the last few years, automated guidance, variable rate application of fertilizer and other inputs, and yield monitor data, taking that digital agricultural tools and combining it with the process of conducting on-farm experimentation empowers farmers to make better farm management decisions under their local conditions and management practices.
Really, what's behind this, then, is the idea of circling back to the more localized information where over the years prior to this, we've seen a slow transgression into more site-specific, small plot research, to put it that way.
Yes, exactly. We're circling back. It has come full circle, Eric. And we're trying to empower farmers to think about this. And with this group, there's 22 of us globally from around the world. There's only a few of us from the United States or North America. Martil Lacoste and Simon Cook are from Curtin University in Perth, Australia. They led the project, and they led this global team. There's lots of drivers to this, and this isn't the only piece of the puzzle. There's a new multi-state research project for universities called NC-1210 that I'm a member of, representing Kansas State University, and it's all about on-farm experimentation. We just had our first annual meeting a few weeks ago, and I mentioned cleaning of yield monitor data, and that's been my contribution of how can we remove the human element when we clean data coming from a yield monitor on a combine or a cotton picker. It's a very tedious task, menial task, that takes a lot of effort, maybe 45 minutes to an hour for each field. And I built automated techniques of doing so. So basically, a farmer can upload their yield monitor data file and a few moments later get a clean data set and another table of what parameters they could use in their desktop software if they wish to arrive at those same clean data set. Mm-hmm. NC-1210 has other things going on. They're looking for ways of automating these processes. And when we think about digital agriculture and what is adopted more readily, it comes down to ways we can replace human capital with automation, automated guidance, automated section control. And we're in the process now of automating the management and analysis of yield monitor data. That's sort of been the holy grail of automating digital agriculture.
So how you envision this whole initiative could serve as a centralized hub for participating producers to interact with researchers for the mutual benefit of both?
Yes, in some ways, but one of the things that we really want to do is decentralize our process. Okay, we want to empower the producers to have the tools and the techniques available to do this on their own without relying upon a centralized location or organization to be the nexus or the hub. We want to decentralize that.
Then how do you see this practically being administered at the farm gate, Terry? And how will it mechanically work for all participants?
So one thing that the group has been working on is this idea of automated experimentation. And the idea is instead of designing the experiment to then go to the field, we'll allow the applicators to use randomization tools. So, if you think of, spreadsheets you may be familiar with, random number generators, and the idea is if we've been applying high rates where high rates are needed, we need to apply high rates where low rates are needed, and vice versa, and all combinations thereof. And so it takes a probabilistic look at what has been applied in the field and then start applying rates that will fill out that grid and the bingo card of high lows and low lows and so forth. That's part of it. We're trying to remove the necessity for humans to look at data, to look at the experimentation process, because even the best scientists sometimes have a bias to them, and we always have these tests about sample bias and survival bias, and so we need to be cognizant about our own biases. And when we can replace humans with an automated, rigorous algorithms, then we can hopefully prevent those human biases from coming into the experiment.
And in that, the producer will gain with more tailored information to their situation.
Yeah, tailored to their situation. So these products are the same products, may be applied across large regions, but we get localized information not only with their soils and their weather regime, but how does that particular farmer treat those inputs? When do they plant? When do they do other activities in the field? And what seeding depth or what row spacings or a cardinal direction that they plant in.
Well, this will be a unique partnership, although, again, on-farm experimentation is not totally new, but you're trying to put it on a much more far-reaching scale. Will producers be invited to sign up for this? How is that going to work?
Yes. So this particular paper that we're talking about, On-Farm Experimentation to Transform Global Agriculture, is online now, and if you look at our social media accounts, you can read it online. NC-1210, we are actively looking for farmers to do proof of concepts of some of these tools. So come out. We have some personnel, some technicians who are on a project who can come out and help implement and analyze the data, and then test to see if our automated techniques are operational, and find out what the barriers are, what the growing pains are from interviews with those participating farmers. There
is some benefit to the scientific community itself, though, is there not, in this?
Definitely. We as scientists are gaining a lot. So one of the things I've been interested in is not necessarily one field at a time analysis of on-farm experiments, but more of analysis of hundreds of fields at the same time. And so no individual farmer would have access to all of those. So I'm looking at fields from dozens, hundreds, maybe thousands of individual farm operations at the same time. And as a scientist, that's bordering on big data in agriculture, and we can apply some of the tools we've been talking about. The next step is artificial intelligence, machine learning, deep learning, and those other buzzwords we sometimes hear on when it comes to big data.
Well, taken, Terry, it seems to its fullest extent, this could change the shape of, research widely, but agricultural research specifically here, in that it will be, again, rendering information that is more specified to an area, to a situation, to a commodity.
And one way of thinking about it could be as simple as every pass through the field could be its individual experiment.
So infinite potential here? Is that fair?
It's infinite potential, yes. And, it's very different than, if you've gone to agricultural universities and studied, you may be familiar with the concept of designing an experiment to test a hypothesis. That's great. That's the theory-driven approach. But we're kind of resorting back to the concept of data-driven approach, where we are asking the data for correlations that we may not have even known what questions to ask at the beginning of the project.
Well, folks can contact you directly if they'd
Sure.
like to inquire more about this.
Sure thing. If you're on Twitter, I'm Space Plowboy, and I'm on agmanager.info website here at Kansas State University.
Very well. Well, wishing you and the wide assortment of researchers here in the U.S. and worldwide all the best in taking this to its greatest extent to the benefit of production agriculture and global food systems. Terry, thank you for coming over.
Thank you, Eric, for having me. It's been a pleasure.
That's Terry Griffin, precision agricultural economist with K-State Research and Extension. Again, he and peers around the globe are taking to the next level this idea of on-farm experimentation as a way of bolstering information for agricultural production in a very localized manner for the use of producers out there. Interested to see where this heads in the coming months and years. We'll be back with more for you on Agriculture Today. Welcome back to Agriculture Today and this week's Milk Lines entry from K-State dairy specialist Mike Brouk. And periodically, Mike keeps us up on milk consumption trends, which are relevant to dairy production, of course, not only broadly, but at the farm level. And Mike does so for us again today. Mike?
Today I'd like to visit with our Kansas dairy producers about what we're seeing as far as marketings of milk and how that affects us as we move forward here in the United States. So our Milk Market Administrative Office does an excellent job once a year of taking a look at milk production and milk consumption across the United States. And they use the month of May as their test month. And they basically, it's a huge accounting process where they go through and look at milk production across the United States, but also marketing a product during that time as well. So we get an idea of where we're at on production as well as consumption. And one of the things that they consider in this is that on a monthly basis, we need about 50 pounds of milk per person across the United States. And that is divided up about 50% of that, or about 25 pounds of that, would be for Class 2 and also fluid milk, and the other 25 pounds would be associated with dairy product like cheese and other hard products. So as we look at that and we look at where we're at here in the United States, they divide the country up in different regions, and is related a little bit to where population is at. So basically there's 4 regions across the United States: the Pacific or the West Coast, the mountain region, the central region, and then the eastern part of the United States. And population in dairy cows actually vary quite a little bit as you look at those different locations across the United States, with the bulk of the population actually being located in the eastern part of the United States. So sometimes as they look at things, they do start grouping some of those areas together. Very typically, they'll group the Pacific and the mountain region together along with the central and eastern region in a separate area. So when we look at that, Kansas would be in the central region. And in the central region, over the last several years, we've grown our cow numbers, and we actually are a bit surplus on milk production compared to our population here in the central part of the United States. But when you include the eastern part of the United States in this, we're actually a bit deficit. So west of the Rockies, when you take the Pacific and mountain regions and you put them together, that's an area of the United States where we're actually surplus on milk production as compared to population. And we're a bit on the deficit side here on the central and eastern side. The interesting thing when we look at the May marketings from 2021, our excess in the west more than made up the deficit on the central and eastern side. So this is the first time this has actually been true in several years. So as you think about what happened to milk prices during the summer, that's partially related to that. We actually were in a situation where our production was greater than what consumption was actually at. However, as we've moved through the last several months, we've seen production decrease a little bit. So we're kind of at that balance point where production and consumption are closer together than what they were back during the summer. Part of that just has to do with some seasonal things, but that has helped our milk price increase. So as we move forward, one of the things that you might want to consider is we will see expansion of our dairy industry here in the central part of the United States that will continue to fill the deficit that we see in the eastern part of the United States. However, in order to get rid of all of the milk that we're producing, we're going to be heavily dependent on exports to increase to take up those excesses that we're currently producing. This is Mike Brouk with K-State Research and Extension, encouraging our dairy farmers to think about, as we expand, how we're going to get rid of the additional milk that we produce.
Thanks, Mike. As always, we'll hear from you again next Tuesday. That's our time for today. Tomorrow, among other things, another visit with Roger McOwen of the Washburn University School of Law. Plus more for you. Please rejoin us then. Meantime, Eric Atkinson for Agriculture Today. This is the K-State Radio Network.